Welcome back, everybody. This is going to be our Algebra 2, Algebra Essentials, Lesson 2, homework review for solving linear equations. This is part 1. And so this stuff is, in this case, going to be pretty much what we did in geometry as well as Algebra 1 now. So a lot of it is be balancing equations and looking at different type of linear equations in this case. And so question 1's got a lot of parts to it. So part A has the whole point in this case is to solve each of the following linear equations. If the equation is inconsistent, state so. If the equation has an identity, also state so. Reduce any non-integer answers to fractions in simplest form. So before we start on these things, we want to kind of like know what are we talking about when we say inconsistent though, and consistent. So let's kind of make sure we cover that now. So if two equations are consistent, then they meet at one point. Okay, meaning they intersect at one point only. If they are inconsistent, then they have no solution. And in some ways, in this case, we'll talk about graphically, there would be two parallel lines with no points of intersection. Okay, and so now the last part we're talking about is identity. And identity in this case would be when all values, meaning in this case any value, so when any value would be a solution for the equation. Now that would mean in this case that identity will be it's basically the left side is equal to the right side no matter what. Okay, so those are these words are consistent, inconsistent, and identity. That's what we'll make sure we talk about here. Okay, so let's go back to our equations. So here we go. So for the first one, we're going to solve this by balancing the equation. I personally like to take care of the variables first. So we're going to undo the smaller of two variables. So 7x plus 5 equals 2x minus 35. 2x is smaller, so we're going to subtract 2x from both sides. And we'll get 5x plus 5 equals negative 35. We're going to subtract 5 on both sides. So 5x is equal to negative 40. Divide both sides by 5, x equals negative 8. And so this here is an example of in this case, we're doing what's called opposite operations. And so here we are trying to get x by itself. For b, we have x over 3 minus 7 equals negative 5. So we are going to now we have the variable by itself. We want to kind of isolate it further by adding 7 to both sides. Give us x over 3 is equal to 2. And so to undo our 3 dividing into x, we're going to multiply both sides by 3 to get x equal to 6. Right, so that's fine too. So C, 4x minus 5 equals 4x minus 1. Now here's the thing. If we subtract 4x from both sides, remember, the equation is balanced, so left side equals right side. We would get negative 5 equals negative 1, and this cannot be. Therefore, this is not true. This is an example of an inconsistent equation. Okay? So I should use a smaller font here. Here we go. The equation is inconsistent, meaning there's no solution, okay? No solution. And you will find in this case in Algebra 2, if you have not had so already in Algebra 1, that there are situations where there is no solution for our problem here. That is, nothing will work out, okay? And again, graphically, we graph both of these, you would have two lines that are parallel to each other with the same slope, but they would have the different y-intercepts and therefore have no points in common. Okay, so here we go for part D. We're going to now take care of that straggler of -1 here by adding 1 to both sides. So let's get that 5 times x minus 3 over 2 by itself. So now I have 5 times x minus 3 over 2 equals 14. And now what I'm going to do here is I'm going to multiply both sides by the reciprocal of this coefficient. You could multiply by 2 and divide by 5, but hey, let's do both at once. So the reciprocal of 5 over 2 is 2 over 5. So we'll multiply both sides by 2 over 5. We're going to get, in this case, the 2's dividing out and the 5's dividing out, leaving us x minus 3 is equal to 28 over 5. Okay? And now add 3 to both sides. Okay, so now, adding 3 to both sides. Well, x is equal to 28 over 5 plus 15 over 5, because that's what 3 is equal to. And that's equal to 43 over 5. Okay, now, if we want to go further and find this as a mixed number, x here would equal to, well, 5 goes into 48 times, the remainder of 3. So 5 and 3/5. You would also get 8, so sorry, 8 and 3/5, sorry, not 5 3/5, 8 and 3/5, or 8.6. So this would be the final answer you would have. I personally like leaving in the improper fraction form, but just in case, some individuals like to have in a mixed number or decimal value. Okay. Now, we would like to isolate x, but we have to now distribute the 3 here. So we would have for E, 3x minus 3 plus 2 equals x plus 9. And so like we learned in the last situation, let me move this over a little bit, okay? We learned in the last lesson that we can combine like terms first, and so we're going to combine, in this case, the -3 plus 2, and we're going to get here 3x minus 1 equals x plus 9. And I always like to subtract the smaller of two variables. So between 3x and 1x, I'll subtract x on both sides. Keep in mind it's 1x here, even though it says 1x. So minus 1x. So 3x minus 1x is 2x, so 2x minus 1 equals 9. Adding 1 to both sides, we get 2x equals 10. Dividing both sides by 2, x equals 5. Okay. All right, and so now for letter F, 4 minus 2 times x minus 1 equals x plus 5 plus x minus 6. On the left side, we'll distribute to get 4x minus 2x plus 2. Be very careful, because in this case, -2 is still -2, multiplying both of these things. On the right side, we're going to have, in this case, x plus x is 2x, and 5 minus 6 is minus 1. Here we'll combine like terms to get 2x plus 2 equals 2x minus 1. Oh, looks like we have one of those situations. If you subtract 2x on both sides, we're going to get 2 equal to -1. And this is not correct, ladies and gentlemen. So we're going to get, in this case, another inconsistent solution. So in this case, inconsistent equation. Inconsistent equation. Okay? All right, so we continue on, and letter G, we're going to distribute. So here we go, distribute to 5, and we get 10x minus 30, distribute to 2, plus 8x plus 6 equals 8x minus 9. Okay, let's combine like terms. So we have, in this case, the 10x plus 8x will give us the 18x. The -30 and the 6 will give us a -24 equals 8x minus 9. Subtracting 8x on both sides. You can also add 24 on both sides too, kind of like in this case, because you're balancing everything out. So you get 10x is equal to, here we get -9 plus 24 is going to be I believe it should be 15. Okay, and divide both sides by 10. X is equal to 15 over 10 or 3 over 2, which is the same as 1.5. Or 1.5, that's okay too. Now h, we're going to actually cross multiply here. Or you could also, if you want to, multiply both top and bottom by 3 for the left side, get the same denominator, but we'll cross multiply. So here we'll have x times 6 will give us 6x, and 2x times 5 times 18 is 18 times 2x plus 5, and they're equal to each other. And so we have in this case 36x plus, now 5 times 18 should be 90, equals 6x. Here, I'm going to subtract 36x on both sides. And you say, well, why do that for? Well, here's the thing. I would have to subtract 6x and then subtract 90. So we still kind of save a little bit on efficiency here. So 90 is equal to negative 30x. We divide both sides by negative 30. And we get x is equal to negative 3. All right, 2 more questions. Whew, this is a lot here. So, okay, I and j. We're going to distribute the right side. So we now have this, and you know what we can do? We can divide the 2 both into the 10x and in the negative 4. So we're going to get on the left side 5x minus 2. Keep in mind that 2 is dividing both of these things. Okay, so 10x divided by 2 is 5x, and negative 4 divided by 2 is negative 2. We add 7 to both, and 7 plus 7. Distribute here with the 5. So we have 5x plus 5. So now we have in this case 5x, and we have plus 5 equals 5x plus 5. Wait a minute here. The left side is the same as the right side. If we subtract the 5x on both sides, we would get 5 equals 5, which is true no matter what. True no matter what. So what it comes down to is, this is an example of an identity. Identity. So that would mean in this case that no matter what number we plug in for x, we would get the left side equal to the right side every single time. All right, so we have an identity here for question I. And finally, for number to letter j, let's distribute here. We have 18 minus 2x minus 14. Again, we're going to divide the 2 into both the 8x and the negative 20 because they are both being divided by 2. And so therefore, we get on the right side 4x minus 10 minus 2. And so combined like terms on the left side, we're going to get 4 minus 2x is equal to 4x minus 12. Here we're going to add 2x because negative 2 is smaller than 4x. So opposite of negative 2x is positive 2x. I'm also going to add 12 to both sides as well. And so now we have, in this case, on the left side, 16 is equal to 6x. Okay? So double check that. And then divide both sides by 6. We get, in this case, x is equal to, now 16 over 6 is the same as 8 over 3, which can be written as, in this case, 2 2/3. Okay, now keep in mind not all answers will be nice answers. So, okay, ladies and gentlemen, hope this was helpful. This is just part 1, our first question with so many questions. I hope you found this helpful, and if you can, give it a like, and make sure to subscribe to the channel. Make sure to look out for part 2, where I will be working on some more questions. Take care, ladies and gentlemen. Be safe.